Hello and welcome to this lecture on propositional logic and ordinary English. So this video is primarily intended for my HUP 112 Logic and Philosophy course, where we are going through the basics at this point of propositional logic. And this class is called Logic and Philosophy, where we try to relate logic, the technical symbolic stuff, with some more philosophical topics. So today we'll be talking about how the formal calculus that we've defined so far in the class relates to ordinary English. So let's go ahead and get started here. I'm going to be using this whiteboard. So just to refresh your memory, we have been introduced to our 5 logical operators in the class. We have a tilde. We're using a dot in this class because of the book we're using. We also have a wedge. We have a horseshoe, and then we also have the triple bar. So the tilde is our negation operator. It tells us that whenever you have a sentence and you want to apply a tilde to that sentence, then if the sentence is true, the tilde reverses it to false. And over here, if it's false, it reverses it to true. Okay. So the dot operator is our conjunction operator, and it tells us if you have 2 propositions, P and Q, and you want to put a dot in between them, then there's 4 cases that result, both true, one or the other being false, or both of them being false. So these are our 4 cases, and the dot says it's only true when both of them are true. Okay. And the wedge operator says if you want to put a wedge between these 2 propositions, and so then you have P wedge Q, then it's only going to be false when both of them are false and true in every other case. And then finally, we have our horseshoe operator, which says if you want to put a horseshoe between 2 propositions, then it's going to be true when they're both true, false when the antecedent is true and the consequent is false, and then true in each and every other case. So that's the that. And then just for completeness, we have P triple bar Q, which is only true when the truth values match. So when they're both true or when they're both false. So I'm going through this. Sorry, this is supposed to be true down here. Oh no. I'm going through this pretty quickly because we've already spent a fair amount of time in the class talking about this. So if you want a refresher, I have a video on this. You can check it out. So now we said that this loosely relates to the word not, and this loosely relates to the word and, this loosely relates to the word or, and this to if, then, and we've been learning how to use these things. So that's all very well and good. But of course, there's some things that we want to discuss. And in order to do that, I think it might help to take a step back and talk about how languages can be studied from 3 different levels. So I've mentioned this in class a couple of times, but I want to go ahead and have a place where it's recorded. So on the one hand, we could talk about the syntax of a language. On the other hand, we could talk about the semantics of a language. And then finally, we could talk about what's called the pragmatics of the language. Now, the syntax of the language, which if you're speaking English and listening to this video, you'd probably be most familiar with from the grammar of English, which is largely where people learn syntax in school and stuff like that. So the syntax as we're using it tells you what alphabet you can use, the alphabet, which are the allowable symbols, and then also how to form what we call well-formed formula, abbreviated WOFs, and I don't make this up. So that's what they're called. So for example, in English, you can have a sentence, a word, for example, dog, which is just an arrangement of the allowable symbols So D-O-G. You could rearrange these and form God. Same symbols rearranged, which is also allowable. But what's not allowable is ODG. So ODG is not a word of English. So the syntax tells you that this is well formed and this is well formed, but this one is not well formed. So you learn stuff like that. And also, for example, for those that may be a little more persnickety about this, we could say that, for example, the dog chased the cat is an allowable sentence of English. So if I write the dog chased the cat, then that is, oops, I should learn how to spell, chase the cat. So that's perfectly allowable. But if I write chased cat dog the, that is not an allowable sentence of English. And of course, the only difference between these two is that this one has the words in a different order. So this one is not well formed. This one is. So without even knowing the meanings of these things, we can say that this is allowed and this one is not allowed. Okay, so that's what the syntax allows you to do. And the syntax, as we've been dealing with in our class, allows capital letters, and then the logical operators, and then parentheses. That's a horseshoe. And then we have the rules, which say if you have a well-formed formula, then putting a tilde to the left of it is a well-formed formula. So if A is a well-formed formula, so is tilde A. And we have the rule that says if you have two well-formed formulas, you can put a dot between them. So if A and B are well-formed, then A dot B is well-formed. And these rules are the ones that we've been learning to know and love. Okay, so the semantics of a language tell you what the symbols mean, what the symbols mean. So gives you the meaning attached to the symbols. And we have been in our class using the truth tables, which I put up on the previous slide, on the previous whiteboard. The truth tables give us the meaning for these things. So what the meaning of the tilde is connected with that truth function of taking true and reversing it to false and taking false and reversing it to true. So now the semantics and the syntax of a language are separate from each other. And I always like my example, which I learned from Facebook. A guy that I know whose name is Ned posted a picture on Facebook, and the picture showed two buttons in an elevator, and it said "hit Ned," and then he wrote a joke underneath it that said, "Why does this country hate me?" I forget where it was, Denmark or Sweden or someplace. It turns out in that language, this means here and there, which are used for up and down. So in English, hit means physically attack, and Ned is a guy's name. But in that language, hit, the same allowable syntactic string, has a different meaning associated with it. So this happens in many cases where you have one syntactic string that has a meaning in one language and a different meaning in another language. So syntactically, they overlap. So for us, the truth tables give the meaning of those symbols. Finally, at the end here, we have, I'll just put it kind of tendentiously to say what people mean. So what the symbols mean, and then what people mean. So for example, famous cases like irony, where you say things that have the literal opposite meaning of what you are trying to communicate. Like if you say, oh, this lecture is so interesting, but you say it in a way where you're rolling your eyes and indicating that you mean the opposite, that you are saying it's interesting, but what you mean that is not interesting. And sarcasm and irony in this way are rampant. People use them all the time. But that's not the only way in which what we mean goes beyond what, or at least what seems to be the meaning of the things that we say. And one of my favorite examples is like if you're looking in your closet and you see like 10 shirts in there, and then you say, I don't have any shirts to wear. Now, of course, I don't have any shirts to wear is false. You're looking at 10 shirts. But what you mean is that you don't want to wear any of these shirts. Or other cases, famously, you could say, I'm ready. Well, ready for what? So maybe in the context, people know you mean ready to go or ready to eat or what, ready for whatever. But it's often that we'll say things that strictly don't mean the same things as what the thing we said means. And of course, there's a big debate over where exactly to draw the boundary. And that's part of why I'm putting these all out here so that we can come back to this at the end of this lecture and remind ourselves of some of these options. So let's keep this in the back of our mind as we move through. So to go ahead and start talking about some of these things. So taking conjunction first, we have our truth table over there, but it's not hard to find sentences of English which ordinary speakers will think don't really have the same meaning as the truth function. So if I say, Jill broke her leg and went snowboarding, as opposed to Jill went snowboarding and broke her leg. So ordinary speakers of English will often say that these sentences have different, what did I do? Oh, I didn't. Yeah, I did it right. Okay. Or ordinary speakers of English will often say that these sentences have different meaning. Now, of course, in our way of doing things, we would symbolize this one. And so if we have Jill broke her leg as J and Jill went snowboarding as S, then this first sentence says S, J dot S, and the second sentence says S dot J, and these two sentences have the same truth functional meaning. They come out true in all the same cases. And it's not hard to see that. So just to quickly prove it, if we have J and we have S, and then we have J dot S, and we apply the truth table here, true, false, false, true, false, false. If we apply the truth table here, then we'll see that J dot S is true here, false here, and false here. So what about S dot J? So now we've reversed these two, but it's not hard to see that you're going to get the same case. So here's S, here's J. So S dot J is going to give you true. This one's going to be false, and this one's going to be false, and this one's going to be false. So sentences that have exactly the same truth function are said to be logically equivalent. And since this is our definition of what meaning is, these sentences have exactly the same meaning. So according to the propositional logic that we've been studying, these two sentences mean exactly the same thing. But ordinary people will say, wait a minute, it seems like there's some sort of causal effect here, maybe, that she went snowboarding and that's how she broke her leg, or some kind of temporal effect that she broke her leg and then went snowboarding. So there does seem to be a kind of mismatch here where people wonder whether or not the truth functional nature is actually capturing what's going on here. So what are we going to say about that? Well, I think that generally speaking, there are three things that you could say. So when it comes to how this sentence here, J dot S, and the truth function associated with it relates to English, one thing you might say is, look, this doesn't capture the full meaning of the word and. What it does is it captures just one meaning, the truth functional meaning. And there are some sentences that have exactly that truth functional meaning. Like, for example, when I say, I want to go by my house, but first stop by my work. So there I'm saying, first stop by my work, dot, go to the house. There you have a perfectly truth functional statement. So maybe that's not the best example I'm thinking to myself, but you know what I'm saying. There are statements in English like he failed the test and today is Tuesday. Okay, so not the most exciting case. But anyway, the point is that there are some cases that seem perfectly straightforward where this is what we're trying to capture. So one thing you could say is that, yes, this is part of the meaning. So that's the first thing you could say is that it gives us part of the meaning, part of the meaning, but not the whole thing. So maybe there's some other kind of meaning associated with and in these cases. And when you translate these kinds of sentences in this way, you're losing part of the original meaning of the word and, so that the propositional logic doesn't say everything there is to say about the meaning of the word and. Now, on the other hand, and some people will hold that this does give you the entire meaning of and, does give entire meaning of and then they will say but people use it in these other ways to indicate what they mean, so but not the pragmatics. So one thing that you might say is that when people say the sentence Jill broke her leg and went snowboarding, as opposed to Jill went snowboarding and broke her leg, one thing you could say is, look, those both have the same meaning, but people selectively use one or the other when they're trying to communicate one or the other of these sentences. So you would say this sentence when she went snowboarding and that resulted in her breaking her leg. And you would use this sentence when you would try to indicate that she broke her leg first and with a broken leg went snowboarding. So it's rather what people do with these things, the pragmatics of it, that gets in the way, according to this other camp. So those are two, I think a large part of the history of the philosophy of logic here related to this revolves around one or two of these options here. I almost said objects, options. So one option being, look, the entire meaning is not captured. There are multiple meanings. The word and is ambiguous. And the other reading, which is that, no, this is exactly what the meaning of the word and is, but it's just rather that people use these words in various ways to indicate other things that strictly go beyond the meaning of the word in a way similar to the way we use sentences ironically, or we say like, I feel like a burrito when you mean you feel like eating a burrito, or you say the various things that we say, which are strictly and literally not what we mean. So this is a deep issue in the philosophy of language. I think there was a time when this one was more popular than it is now. I think maybe this one is more popular. But you could see how there's two different options here. Now, a kind of third option that you could have is to say, well, look, this is never really meant to capture the meaning of the word and. So it's not, so this camp says it gives the entire meaning. This says it just gives part of the meaning. One other kind of camp says, look, this is an idealized, simplified way of talking about meaning. Maybe meaning isn't fully captured by the truth functional analysis at all. So that would be a third option. Okay, now what's interesting is you see sort of exactly the same thing playing out with the word or. So for example, we remember our truth functional definition of the word of the wedge. The wedge tells us that when your propositions are both false, then you get false, but you get true in every other case. So when you have A wedge B, and this one is true and that one is true, then the wedge is true. And when one or the other is false, you have the wedge being true, and it's only down here where you get the entire sentence being false. So this is typically called inclusive or. inclusive or, because it allows the possibility that both of them are true. So, for example, sometimes people don't like this. If you say, tonight we go to the movies or go to dinner. Okay. Um, wait. Why can't I? Oh, text boxes. I can't resize these. Um, you know what? I don't even really care. You can see the sentence. It seems like it's a little bit cramped. Why is this happening to me? Badoo, badoo, badoo. Okay, anyway, it doesn't matter. So tonight we go to the movies or we go to dinner. So a lot of people will take a sentence like this to um, to indicate that you can do one or the other. And then if you say, well, look, tonight, so suppose that's what you say to your friend, look, tonight we can go to the movies or we can go to dinner. And suppose so you go movies or dinner. And suppose you end up doing both. Suppose you see the early movie and then catch dinner afterwards. So is your sentence that we go to the movie or eat dinner true? Question mark. Well, propositional logic says that it is, but a lot of English speakers are a little bit suspicious of that. Another kind of example that you might have is suppose you have a checkerboard like this, and some of the squares are black as so. And then you say this board is either black or white. Okay. So this board, don't make me write ARD. Okay. This, I should have typed it out. But anyway, this board is either black or white. So is that true or is it false? Well, if you translate that as this board is black or this board is white, then it's true in both cases. And the truth functional analysis over here says the sentence is true. So a lot of people don't like that because they think that the word or somehow rules out that condition. And they think instead in terms of what we call exclusive or. So exclusive or in English sometimes is written and or excuse me, inclusive or is sometimes written and or to make it very clear. But we say that the inclusive sense of or is the default one. So exclusive or basically tells you that you can have A or B, but you can't have both of them, but not A and B. And if you do the truth table for this, which we could very quickly do here. So if A is true, but B is false, and this is false, but that is true, and they're both false, then A or B is true. This just follows the pattern. Sorry, this is supposed to be true. This is why I use PowerPoint. Okay, so true, 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 false. And then over here, we have A and B. So that's going to be true, false, 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 just using these same values. This tilde reverses those. False, true, true, true. And now we look here to put the and. So true and false makes that false. True and true makes that true. True and true makes that true. And then at the end, you get false. So there you go. So exclusive or is going to be ruling out this very first case here, where you have both A and B being true. So if you wanted to say sometimes there's a symbol for this. I think, what is it? Is it X in a circle? I always forget. Plus in a circle is from math. That's a tensor, maybe. I don't know. X in a circle, I think. So you can say X, and this is sometimes pronounced X or. I think in computer science, they use this more often than we do in logic. But you could define a new operator and say it has this truth value function over here, where when these two are true, the first line is false. And then you might want to say, well, okay, there's two meanings of the word or. There's the inclusive or, and there's the exclusive or. And in English, you find examples of this. Like if you say, it won't rain unless there's clouds in the sky. So it won't rain unless there's clouds in the sky. It will not rain unless there are clouds in the sky. That looks perfectly fine. But on the other hand, so this one looks pretty fine. It says either it's not raining or there's clouds in the sky. So could you have both of these being true? Well, there could be clouds and no rain, right? So you could have a cloudy day and false that it's raining, so making this one true. So that looks like a perfectly good case of inclusive or. But on the other hand, if you say things like that wood will burn unless it's wet. So the wood will burn. I guess I should not use W for both of these. I'm not being very systematic here. So you could say that wood will burn unless it's wet. We use or to translate unless. What you really are trying to say here is that it can't be burning and also wet. So you want it to come out this way. You want it to come out this way. And now there are other examples too. Like you could say chicken's not properly cooked unless it's a certain color. I don't really know. I don't eat meat, so I guess that's a bad example for me. But you might, what color? Pink, unless it's pink, or is that bad? Is it white? I don't know. Anyway, the point though is that there are some expressions which seem to want it to be the case that only one of these can come out true, which is what this middle area here is. There's A is true or B is true, but it's not both of them being true. So once again, you ask yourself, what do we want to say with respect to the relationship to ordinary English? And I think you have exactly the same options that we talked about before. So you could say, look, there's multiple meanings of the word or. There's inclusive or and there's exclusive or. And people use both of these and they just are different meanings to the word or. Or on the other hand, you could say, well, no, there's only one meaning to the word or. And instead of exclusive or, there's this thing, which is a different truth function, but it's built up out of the stuff that we already know. So we tend to say in propositional logic that inclusive or is more fundamental because it doesn't need to have all these other bells and whistles attached to it. So you have a dot, you have a tilde. Oh, wait, I use a dot and an ampersand. Okay, sorry about that. This should be a dot. I should be consistent, either make both that or both that. Anyway, so those are just alternates. Everyone uses different symbols. As long as you mean conjunction, that's really what matters. So in this case, it seems as though you could say, look, there isn't two meanings to the word or. There's just one meaning to the word or. But sometimes, and that's inclusive or. But sometimes people use the word or to indicate this thing, which is the more restrictive kind of case where you're not allowing both of the first two. So once again, we have our two options. You could say, look, there's two different meanings for there's semantically, there's two different meanings. And we could capture both of those in our language. Or you might say there's only one meaning for the English word or, and the rest is pragmatics. So this is a pretty deep philosophical issue about what we're supposed to say here with respect to these kinds of statements. I'm not here to really tell you which way to go. I'm just here pointing out that there is this kind of philosophical puzzle about what the relation of all this stuff that we're doing is to the English that we are saying it's related to. Now, finally, coming to the end of this, we have the horseshoe operator. And if we say a horseshoe be, then as we saw, this is going to be true in the case where both parts are true. And then it's going to be false where the antecedent is true, but the consequent is false. And then it's true in every other case. It's true in every other case. And sometimes people think this is a deep puzzle. In fact, sometimes this is called the paradox of material implication, because you could basically see that there's some kind of strange results here. So on the one hand, you could say, well, look, as long as B is true, then anything implies it. So if B is the case, then any sentence implies B. So for example, pick something true, like I live on Long Island, which is true for me. So I live on Long Island. Technically speaking, this should be Richard Brown, yours truly. Richard Brown lives on Long Island. So then any sentence at all can be connected by a material conditional and it will come out true. So if the moon is made of green cheese, then Richard Brown lives on Long Island. Okay, so this sentence comes out to be true. So the moon is made of green cheese. I suppose that's false, but it's true that Richard Brown lives on Long Island. So that's this case right here. And that therefore comes out to be true. Now, if it happened to be true that the moon is made of green cheese, like suppose we all found out tomorrow, if this sentence would still be true, because the consequent is true. And you can see that when the consequent is true, that this sentence will always be true. So that's a bit of a strange result. We can see it going the other way as well, because if the antecedent is false, then you can see that the whole sentence turns out to be true. So let me just erase this here. And we could sum that up by saying, if the antecedent is false, then anything whoops. Oh, sorry. Hold on. The phone's ringing. All right. Sorry about that. So on the other hand, if A is false, then A implies anything that you want. So for an example of this kind of statement, you could say, if Richard Brown is a serial killer, then he is a good teacher. An example I've used before, I have a different video on this exact topic from a while back, but nonetheless, okay. So if Richard Brown is a serial killer, then he's a good teacher. So notice Richard Brown is a serial killer is false. I'm not a serial killer. So I made that F unusually long. And then Richard Brown is a good teacher. Well, some people will say that's true. Some people will say that's false. But notice that it doesn't really matter, because as long as this part over here is false, then it doesn't matter whether the other side is true or false. The sentence comes out to be true. So this is sometimes, but we say this is a true sentence. If Richard Brown's a serial killer, then he's a good teacher. If the moon is made of green cheese and Richard Brown lives in Long Island, we say that's a true sentence. And many people just violently reject the possibility that these sentences are true. Now, in fact, this area has received a lot of attention in philosophy. We will later in the semester talk very briefly about three valued logics. And then maybe by the end of the class, we'll talk about modal logic. And both of those have been areas that have been developed as in a way in response to this. So we may come back to this paradox of material implication. For now, we can just say, well, why do we even accept this at all? Well, the first thing to say is there are cases where there are sentences of English that come out the way you would expect, given the analysis we have here. So if I suppose I had a box and I say there's an animal in this box, well, that seems kind of mean. Suppose I say there's a fruit in the box. Suppose I have a box here. Suppose I have a box and I say there's some kind of fruit in here. And then you say, well, I don't know what kind of fruit it is, but if it's an apple, then, well, I don't know what you want to say. If it's an apple, if it's an orange, then it's citrus fruit. So suppose you said that if an orange, then citrus. I don't know the official name for oranges. Okay. And then suppose what I pull out is an apple. Well, it's false that it's an orange and it's false that it's citrus, but it seems like it still should be true that if it's an orange, then it's citrus. So that seems like a case where the conditional holds. On the another kind of example of this, it is suppose that I say there's a shape in the box, and you say, well, if it's a square, then it has four sides. Okay. And then suppose out of the box, I pull this trapezoidal thing. Okay. So it's false that it's a square. It's true that it has four sides. So this is this line of the truth table. So what do we say? Well, it seems like it should be true that if it's a square, then it has four sides. So there are, even though that this particular thing that we're talking about turns out to be not a square. So it does seem as though there are cases where material implication is the right way to analyze indicative conditional statements. And then there are these other cases where it seems really weird to analyze them that way. And then you have to ask yourself, what is it that we're supposed to do? And this kind of is compounded even further by recognizing that if you don't treat things this way, then it's really hard for us to say that certain arguments come out to be valid and that other arguments come out to be invalid. So just really quickly, if we take an argument form that says P horseshoe Q, and then the second premise is P and the conclusion is Q. So this is a valid argument form, and we can prove that it's valid given our truth functional analysis. So suppose that both of these sentences are true. Well, so if P is true, then P is true here. Is it possible to make this sentence true and the conclusion false? No, because if this is false, then the whole sentence is false. So this can't be false. So, well, this has to be true by that reasoning, which means that if both of the premises are true, then the conclusion is true. So this has to be the way that it works for at least that, right? So at least this part has to work that way. Now, take an invalid, so this one is valid. Take an invalid argument where you have P horseshoe Q, and then the second premise is Q, and the conclusion is P. So what about this case here? Well, can you make both of these premises true and the conclusion false? Well, suppose that this is false. So that means it has to be false here. And suppose that this is true. So that means it has to be true here. So what are you going to say about this sentence? That's the one where this is false and that is true. We know this is an invalid argument. So we have to make this sentence true, it would seem. And that's a powerful reason for thinking that, well, that line of the truth table has to be that way, because if it wasn't, you couldn't get a counterexample to that case. Or again, take the example of modus tollens, which is as follows. So how do you make these two sentences true? Well, tilde Q here, if that's going to be true, then P has to be false. Okay. Excuse me. Sorry. Q has to be false. So what are you going to say here? Can you make this conclusion false? Well, if you did, that would make P true. So that would be a case where this is false. So you in order to preserve this, in order to make it come out right, it's got to be the case that this one in this arrangement comes out to be true. And then you would say that the conclusion is true down here. So this is a case where you have both of them false. And it seems like you kind of need that in order to make the argument not susceptible to counterexamples. And over on the other side, it seems like this one, where one's false and the other one's true, it seems like you need that in order to be able to generate the counterexample. And you could play around with this and also come up with one where both of these are false and you need that to get a counterexample. So if our way of thinking here is on the right track, then what it's revealing is that this does capture the arguments that we want to say are valid and the arguments that we want to say are invalid. And then it's not clear what exactly you want to give up. So later when we come back, we'll look at ways that people have tried to say that maybe these arguments aren't valid in certain instances, or that we can still show they're valid in particular cases, but maybe there's got to be some other way of dealing with that. So that's a lot to go ahead and throw out there, but this is just to get us thinking about the relationship between the propositional logic that we've been talking about and the natural language that we often speak. I guess before I leave, I should say something about the other class of conditional statements, which I haven't been talking about, and that may lead us into some territory that we'll come back to. So if you say, if I had been taller, if I were taller, let's say, if I were taller, I could reach the ceiling. Okay. So now it's false that I were taller. So I'm not taller. I'm exactly as tall as I am. So this is, you don't want to say that this sentence is true. So what we often say, this is a different kind of conditional statement. This is called the subjunctive or counterfactual, where you say something, you know, if Hillary had won, then the country would be in better shape or worse shape or whatever. But you start off with something that actually is false. And then you say, if that had happened, or if it were the case, then something would happen. So these counterfactuals involve modalities related to possibility and necessity. Like, is it possible that I could have been a little bit taller? Or is it necessary that I be exactly the size that I am? These are the questions that get us into modal logic, which is the logic of necessity and possibility. So we'll probably come back later in the semester and deal with that and try to use what we say about that to analyze maybe the regular conditional statement. That's a very popular strategy. At any rate, there's a lot more to be said about this. So this is just the beginning of this, and I'll see you guys in class. Or if you're watching this online, then I won't.